Solving double-angled trigonometric equations. Okay, we're going to look here. We've learned to solve for double-angle equations graphically as reviewed below. So we have done this question or similar question where we would solve the left-hand side. And so it was possible that we had a 2 or a b value other than 1 over the domain shown. And this domain was between 0 and 360. So it's kind of hard to tell in this graph, but it was between 0 and 360. So this is where you would graph y equals 2 sine 2x, which they graphed. Often I'd give you that picture, though this is one we could graph. And then the horizontal line y equals 1. And what would happen is the solution is the x values of the intersection points, which I've drawn in for us. So this was 15, 1, this intersection point, 75, 1, 195, 1, and 255, 1. This was in degrees. This is how it would have looked on a graphing calculator. So the x values are simply 15 degrees, 75 degrees, 195 degrees, and 255 degrees. Let's look at how we could solve this particular question then algebraically. And we're only going to look at double angles, but the method would be similar if we had like 3x or a 3b value. So to solve this one algebraically, we're going to isolate sine 2x. So keep in mind this 2 has to stay with this x. So when I'm dividing off the 2, I'm dividing off the amplitude. So sine 2x equals 1/2. I still use my special triangles. Even though I don't have x completely, I'm solving for 2x first. So my triangle's drawn here. So my reference angle for 1/2 would be opposite over hypotenuse. So pi by 6. I realize here this is in degrees. So pi by 6 is actually 30 degrees. I could have put my triangle in degrees already, but out of habit I used radians. What quadrants is sine positive in? So we're still going to follow those rules. Quadrant 1, so 2x, remember it's still 2x is equal to 30 degrees. And in quadrant 2, 180 minus 30 would give me 150 degrees. All right, so what would happen is because this, if you remember the graph, this would have actually been squished in and compressed by 2. So what we're going to have to do, whenever it's a 2x, you would add one more revolution. There's going to be 4 answers. So you add a revolution. If for some reason it was 3x, you would add 2 revolutions. So in quadrant 1, we would say 2x is equal to 30. A full revolution is 360. So we would have 390 degrees. And then here we'd have our 2x equals 150 degrees. Add that revolution and we get 510 degrees. Now the reason I just didn't go plus 360 here is 30 and 150 are answers, and so was this. So it wasn't just 2 answers at the end. All right, now this is what 2x equals. To get x by itself, you're going to divide by 2. So I'm just going to go over here. Maybe let me just kind of clarify. So 2x so far is equal to 30 degrees, 150 degrees, 390 degrees, and 510 degrees. So divide off the 2 for each angle. So x would equal 15 degrees, 75 degrees, 195 degrees, and 255 degrees. So I'm just going to make a note that we divide by 2. Sometimes I don't necessarily show dividing by 2. I just say divide by 2 and then I list them all here. So there's your answer. Notice, of course, that it's the same as what we would have gotten when we solved it graphically.